This video will let you know about some new types of inequalities that you haven't experienced before, but they do show up in algebra, and they are called compound inequalities. It's very much like in English class when you have compound sentences. You join two sentences with a conjunction word. Well, in the world of algebra, you will join two inequalities with a conjunction word. All right, so compound inequalities are two or more inequalities joined together with the words and or. Those are the only two types of compound inequalities that we have. Right, so we're going to explore and take a look at examples and characteristics of each type. So the first type that we're going to take a look at are the or ones. Right? And then the second type, obviously, we'll take a look at the and ones. So the first thing with the or inequalities is that they have a tendency to graph apart, right? Which also means outside. So when you go to shade your number line, you will have two dots on it, but the shading is going to go outside towards the outer edges. All right, so for instance, when we go to graph x is less than or equal to -2 or x is greater than 3, both of these inequalities are going to sit on the same graph. So you start by x is less than or equal to -2. That means on -2, I put a solid dot, a closed dot, and because it's saying less than or equal to, I shade to the left. For x is greater than 3, I go to where 3 would be, and it is an open dot because there's no piece of the equal bar, and it says greater than 3, so all the numbers greater than 3 are to the right. So you can see what I mean by graphing apart or graphing towards the outside. Okay? And another way that you can look at this with or problems is the opposite direction. So all of those will help you remember what the graph looks like. Each graph is different for each inequality. Don't worry about anything related to interval notation. That's something that happens in Algebra 2. Okay, so you can scratch through that anytime you see it. All right, so when we go to the examples where you have to solve and graph them, we will not write them. You need to be able to take the problem that you're given and solve it based on your rules for solving inequalities, and then take your final answer and represent a graph for it. Right? So we're going to do the odd numbers on this entire note taker. So for number 1, if I want to solve this first inequality for x, then I have to add 4 to both sides. Just like you would when you're solving any equation or inequality, you do the opposite operation. So this gives me x is less than -3. The word or has to be in your answer, so you just bring it straight down. And then on the right-hand side, to get rid of the 2, we have to divide by 2. We are not dividing by a negative, so there's no reason to flip the symbol. So this will mean x is greater or equal to 6. So there's our compound inequality. Now we need to represent it on the picture. Less than -3 would be an open dot on -3. Less than would be left. Greater than or equal to 6 would be a closed dot on 6 and going right. Okay, so that's what the picture looks like for the inequalities answer that you just solved for. All right, so jump down to number 3. These are two-step inequalities that are stuck in here, but you still do the same thing you normally would. So for the left side, we would need to subtract 9. That gives us 2x is greater than 8. We would divide by 2. We do not need to flip, so x is greater than 4. Bring the word or down and go to the other side and solve that one. So we need to minus 10 first. That gives us 5x is less than 0. We need to divide by 5. No need to flip the sign. X is less than 0. All right, so when we go and look at our graph, we need to graph x is greater than 4. So that would be an open circle on the 4, greater than goes to the right. And x is less than 0, so an open dot on 0, and less than 0 would go to the left. Notice all the graphs that I've been drawing lately for these or problems shade in opposite directions, outside, okay, apart, whatever word you need to help remember it for you. All right, then we get to number 5. And we do need to distribute first on this left one. So that means -6x minus 3 is less than -15. We add the 3. That gives us -6x is less than -12. We are going to divide by -6. Because we are dividing by a negative coefficient, we have to flip the symbol to the other direction. So less than becomes greater than +2. Bring down the word or, and we solve the other side. Okay, so for this one, we want to take and subtract 1. That leaves us with negative x is greater or equal to 4. You can't have a negative x. Remember, there's a -1 coefficient, so to get rid of it, we divide by -1. We divided by a negative, so we need to flip the sign, and x is less than or equal to -4. Right, so that's the other piece of your answer. X is less than or equal to -4. So this entire thing right here is what we're going to graph. Right, so on your number line, x is greater than 2 would be an open circle on the 2 going to the right. X is less than or equal to -4 would be a closed circle on -4 shading left. All right, so now before we go to the next type, let's go ahead and put some notes up here in the left-hand margin about the OR inequalities. The first thing you want to put up here that you should have been noticing as you were graphing and doing these is that the inequality symbol, whichever one it is, they will always be in opposite directions. So in other words, when one of them is less than, the other one has to be greater than, or it's not an OR inequality. So one thing you can do for yourself is take the word OR, and to help you remember it, the O is a very prominent letter because it means opposite. It also helps you remember how to shade them on the graph. So keep that connection with the letter O, and that'll help you remember what to do on the OR ones. All right, let's go ahead and switch to the second type, which are the AND inequalities. Okay. And inequalities have a tendency to graph together or in between. Might be a little useful to help you. So you're still going to have 2 dots because you're doing 2 inequalities joined together. Okay, but the shading this time is going to look a little different. So for example, the x is greater or equal to -6. Well, here's -6. Okay, and greater than would go to the right. Then x is less than or equal to 1. Here's the 1, again a shaded in circle, and less than or equal to 1. So you're going to notice that they are shaded in between those 2 numbers. Right? And again, we are not doing the interval notation piece, so don't worry about that. All right, so when you're rewriting AND inequalities, it's a little different than the OR ones. The OR ones have to have the word OR in the answer or it's not done. But the AND ones don't need the word AND in them. You'll notice that all the examples below do not have the word AND, and that's how you can recognize the difference. The OR ones do have the word OR and the AND ones don't have any words. Right? But there is another way that you have to be able to condense them or write them to not have the AND word. So because these fall between 2 endpoints, they are written in a more condensed way. So that same example above, x is greater or equal to -6 and x is less than or equal to 1, will never be written that way because that's got the word and in it. You'll never see it that way. The way you're going to see it is you're going to take the 2 numbers and you're going to put them on the outside edges. And you always want to go from least to greatest. So -6 was my smallest number, I put it first. 1 was my largest number, I put it last. And then because you are shading in between those 2 dots, the letter x, or whatever variable you're using, always goes in between them. Right? So it's showing you in this inequality that you can never go beyond the -6 or the +1. You have to stay in between them. So the way we do this is you use the one on the right first, the x and the 1, and it shows you right here in your original problem that x has to be less than or equal to 1. Right? Well, the nice thing about AND problems is whatever direction you just made that one be, the other side has to also go the same direction. Okay? So even though in the problem it says x is greater or equal to -6, we had to switch it around because now it says -6 is less than or equal to x. It's the same thing, it's just written backwards. So it might be a little weird to you at first until you get the hang of it, right? But I'll hopefully give you some hints of the trade that'll help you with straightening that out. All right, so the first thing we want to do, okay, is go ahead and put those hints over here under the column side. All right, so just like we did on the front, we want to add some extra notes to this. All right, so the first thing we want to make sure we mention and that you understand is that in these types of problems, the inequality symbols both face the same direction. Remember, in the OR ones, they went in opposite directions. Okay, but in an AND problem, they both have to be less than, or greater than, greater than. They cannot be opposite directions. All right, so that's one piece that'll help you out. And then the second piece that'll help you out, if the numbers are in order, least to greatest, the signs will always be either less than or equal to. So if you have your answers in order, littlest number first and largest number last, these are the only two possible signs that you would need, and it just depends on which one they give you in the problem. Then if you have them from largest to smallest, then they're going to be the reverse. But we always want to try and keep them from smallest to largest. All right, so let me see if I can use some of these examples to help you see what I'm talking about here. Again, cross off this interval notation business. We're not dealing with that. All right, so number 7, because remember I said we're doing the odd problems together. When you have an AND problem, you'll notice there's only one X, and it's in the middle of the whole problem. So to balance this as you solve it, what you do in the middle, you have to do on the left and the right. Where those inequality signs are, those are like your walls. Remember in equations, we put a line right down the middle of the equal sign, and that was how we balanced it. Same thing happens here. You just have to do it 3 times instead of twice. So if I want to get X by itself, I'm going to have to add 13. What I do in the middle, I also have to do on the left and the right. And then it cancels the middle piece out. So negative 27 plus 13 is going to give me negative 14. I still have less than. I still have 7x in the middle. I still have less than. 8 plus 13 is going to give me 21. All right, so now I still have a number attached to the x. I need to get rid of it. And we get rid of it just how we always have been. 7's connected to the x by multiplication, so I want to divide by 7. If I divide by 7 in the middle, I have to divide by 7 on the left and the right. I do not need to flip any signs because I wasn't dividing by a negative number. All right, so negative 14 divided by 7 is negative 2. Bring down your less than sign. We now have x in the middle. Bring down your less than sign. 21 divided by 7 is 3. So notice I have the littlest number first and the largest number last. And look what direction both of my symbols are going in. That's what I was talking about in that hint right there about the signs. Okay, so if it's not happening, you know you did something wrong. Now we do need to make a picture of this. The nice thing about this is those two numbers at the end, those are your two dots. So because negative 2 has a less than sign, negative 2 is going to have an open circle. The 3 has a less than sign, so that's an open circle. And because it's an and, look where the x is located. The x is located in between the negative 2 and the 3. So you're going to shade in between your negative 2 and 3 circles. All right, so let's go ahead and jump down to number 9 and finish up there. In number 9, again, find the two symbols and put your walls in there so you can see what you're doing. Okay, you can get rid of the fraction first if that's what you choose to do, or you can move the 1 first. I'm going to go ahead and move the 1. So if I want to move the 1, I'm going to subtract 1 from the middle, the left, and the right. Okay, and then that gives me negative 1 minus 1 is negative 2. Okay, and that's less than. I still have 2/3 x, and then I have less than or equal to 5 minus 1, which is 4. All right, now at this point, I don't like fractions. I'm going to go ahead and get rid of them. You could have gotten rid of them at the very beginning. You get rid of them the exact same way you did for equations. You multiply the entire inequality by that denominator. That means the left, the right, and the middle. Everything gets affected. So 3 times negative 2 is now negative 6. I still have a less than sign. The 3 takes the 3 off the bottom of the fraction, so I now have 2x, and then bring down less than or equal to. And 4 times 3 is 12. So those of you who don't like fractions, you now have a safer way to get to the answer. Right? And then because the x still has a 2 connected to it, I'm going to divide everything by 2. I do not need to flip anything. Okay, so I have my answer is going to be written as negative 3 is less than x, which is less than or equal to positive 6. And if you notice, it's in order least to greatest, and they're both pointing to the left, just like I told you they would be in the hint. All right, now in terms of graphing it, we need to put our dots and our shading piece. Negative 3 is going to be an open circle because it has the less than symbol behind it. 6 has less than or equal to, so 6 is going to be a closed circle. And because X is in between them, we are going to shade in between them. All right, so you've now seen the difference between the two types of and or inequalities. Your job is to go back and finish all the even problems and see what questions you still have when you come to class so we can answer them.